We all want that incredible, powerful AI right in our pockets. But let's be real, that intelligence comes at a price we pay every single day with our batteries just dying on us. So, what if the solution wasn't about working harder, but smarter? Today, we're going to dig into a really cool breakthrough that uses AI to design the very chips that'll power the AI of tomorrow.
So here's the game plan. First, we're going to look at the problem, what I'm calling the AI squeeze. Then we'll explore this kind of wild solution called good enough computing, see the special hardware it needs to work, and finally, we'll meet the AI designer, AxOTreeS, that pulls it all together.
All right, let's kick things off with a problem I am sure we've all felt.
It's so frustrating, right? You download some amazing new app that uses AI, maybe for editing photos or something, and boom, your battery percentage just plummets. This isn't just your phone acting up, it's a really fundamental challenge in how we design hardware.
Yeah, see, every single chip designer is basically fighting this constant three-way war. They need top performance to make things fast and a tiny area to make it actually fit inside your device, but pushing for both of those almost always costs more power, and that's what absolutely kills your battery. For these heavy-duty AI tasks, this trade-off has become a huge, huge bottleneck.
So, how in the world do we get out of this mess? Well, the answer is a little weird. What if the goal wasn't perfection at all?
And that brings us to this idea, approximate computing. The core concept is that for certain jobs, like a lot of AI tasks, which are surprisingly resilient to tiny errors, you just don't need 100% mathematical perfection. If you can accept, say, 99.9% accuracy, you can get these massive boosts in power savings and speed. It's all about being strategically imperfect. Think of it this way. You would never use this for calculating a rocket launch, where every single decimal point is life or death. But for identifying a cat in a photo, who cares? If a few pixels are a little bit off in some middle step, the AI's final answer is still going to be cat. By accepting close enough for the right kind of tasks, we get these huge efficiency wins that our phones and gadgets are just desperate for.
Now, this brilliant idea of approximation, it really needs the right kind of hardware to work its magic. It needs a flexible canvas.
And that's where the FPGA comes in, the Field Programmable Gate Array. See, most chips, the ones you're probably familiar with, are ASICs. They're built to do one thing, and they do that one thing forever. FPGAs? They're totally different. They're like these amazing digital Lego boards that you can rewire on the spot for totally new jobs. And that flexibility is absolutely perfect for trying out thousands of different approximate designs to find the very best one for a specific task.
So how does this actually work? Well, deep down, FPGAs are made of these tiny little building blocks called lookup tables, or LUTs. We can create an approximate circuit by, believe it or not, just turning some of them off. Fewer active parts means less power being used and faster results. But, and this is the big question, with billions of possible combinations, which ones do you turn off?
And that brings us to the hero of our story. A brand new AI-powered method for figuring out exactly which switches to flip.
As the researchers themselves put it, this is not easy. I mean, just one little 8-bit multiplier chip can have 36 of these configurable parts. That means you're looking at billions upon billions of possible on or off combinations. Trying to find the best one is just an insanely complex problem. You can't just guess your way through it.
So what AxOTreeS does is it reframes the whole problem as a game. And to play this game, it uses a super powerful AI technique called Monte Carlo Tree Search, or MCTS. This is the same kind of algorithm that famously mastered the incredibly complex game of Go. Only this time the game isn't about placing stones on a board. It's about building the most efficient chip possible.
Okay, so MCTS plays this game in 4 simple steps. First, it selects the path that looks most promising so far. Then, it expands the search by trying a new move, like turning off one specific component. Third, it runs a quick simulation to guess how good that new design will be. And finally, it learns from that result in a step called update, tweaking its strategy to favor moves that lead to a win. It just does this over and over thousands of times, getting smarter with every single round.
So the big question is, does playing this game actually work? Let's check the scoreboard and see how AxOTreeS stacks up against the competition.
This table really simplifies everything. You see, older methods either didn't optimize at the individual component level, or they just used a kind of random brute force search. AxOTreeS is the first to combine both that super detailed, fine-grained optimization and an intelligent directed search. It's not just wandering around looking for an answer, it's exploring with a real purpose.
So what's its secret sauce?
Well, before it even starts playing the game, AxOTreeS does its homework.
It runs a whole statistical analysis to figure out which of those little components have the biggest impact on performance and accuracy. This lets it guide the search intelligently, focusing its energy where it's most likely to get a big win.
And the results? Well, they're pretty clear. These charts show the overall quality and variety of the chip designs that were found. It's a metric they call hypervolume. Just think of it as a total score. A higher bar is better. And in both tests, AxOTreeS, that's the green bar, consistently finds a better, more diverse set of 18 designs than any of the other methods.
So just how much better are we talking? Well, for the really tough design problems, the ones with super tight constraints, the paper reports that AxOTreeS finds solutions that are up to 1.6 times better than a standard approach. That is a massive, massive improvement when you're trying to push the absolute limits of what's possible.
Okay, so let's zoom out for a second and think about what this all really means for the technology we use every single day.
The takeaway here is huge. This research is paving the way for us to run way more powerful AI right on our phones and gadgets, without completely draining the battery in an hour. It means more efficient data centers, which is a massive win for the planet. And on a deeper level, it signals a whole new era where AI isn't just the software we use, it's a critical partner in designing the very hardware that it runs on.
And that kind of leaves us with this fascinating final thought. In a world that's always pushing for absolute perfection, maybe the most intelligent path forward, especially in the world of AI, is to finally understand the incredible power and efficiency that comes from being strategically and brilliantly good enough.